So we're going to try another example together. We'll do carbon dioxide this time, and we're going to use the same process that we used before. So if you need to, look back at your steps. The first step was to check and see which element should be the central element in this compound. So we want to compare carbon and oxygen and see which one is closer to the center of the periodic table. Obviously, carbon, since it is the center of the periodic table, is closer to the center of the periodic table. There's also just one copy of carbon, which can be another hint that that is the central atom. So I'm going to draw my carbon over here. The oxygens are going to be connected to the carbon with bonds. So those are going to be the outer or peripheral atoms in this compound. So now I've done step 1 and step 2. I found the central element, and I drew pairs of electrons to join the central and the outer atoms. You might also remember that the oxidation number could be equal to the number of bonds. So that would be a clue that our diagram is not complete, because carbon's oxidation number is plus or minus 4, and oxygen's is minus 2. That means carbon would expect to have 4 bonds, and each oxygen atom would expect to have 2. We'll come back to that in a minute. Next, we're going to calculate the total number of valence electrons. So if we look at the periodic table, carbon has 4 valence electrons. So I'm going to use this section down here. And for carbon, I'm going to put 4. Then I'm going to add the valence electrons that oxygen has. Since there are 2 oxygen atoms, I'm going to do 2 times the valence electrons for oxygen. If we look back at that periodic table, we can see that carbon has 4 valence electrons, and oxygen, because it's in group 16, has 6. So that's where I'm getting this 6 from. If I add these up, it would be 4 plus 2 times 6, or 4 plus 12, which would give me 16. Now I want to go ahead and subtract the electrons that I already included in my drawing. The electrons that I included are these 2 lines, which each represent a pair of electrons. So I'm going to subtract 4 electrons that are already used in my drawing. And that means I still have 12 valence electrons to add to this drawing. So remember that carbon is going to want to have 8 valence electrons, and oxygen is going to want to have 8 valence electrons. And so if we add the valence electrons, we could start with oxygen, for example. I would add 1, 2, 3, 4, 5, 6, so that this oxygen now has 8, including the bond. And I would add 1, 2, 3, 4, 4, 5, 6, so that this oxygen atom also now has 2, 4, 6, 8. And I've used up my remaining 12 valence electrons, right? So oxygen has 8 valence electrons, but carbon only has 4. And I mentioned earlier that the oxidation number could be a clue as to the number of bonds that we need to include. So carbon is not happy even though oxygen is. So I'm going to go back for a second and take out a few of those electrons. And then instead, I'm going to add a double bond here and a double bond here. So now we have 2, 4, 6, 8 valence electrons. 16 minus 8 would be 8. I'm just going to scribble this out because I don't know where the eraser is. And that means we should have 8 dots. We have 2, 4. I can add 2, 4 over here. So we now have 8 valence electrons included in the bonds and 8 valence electrons that are lone pairs drawn as dots. And if we check, now carbon has 2, 4, 6, 8 because each bond counts as a pair of electrons for carbon. And each oxygen has 2, 4, 6, 8 because both the bonds and the lone pairs count towards oxygen's total. So now all 3 elements have what they need, which is 8 valence electrons. And we only used the 16 total valence electrons that we got when we added up what they had to begin with. But we have a complete compound here. So I'm going to take a screenshot. And And then I'm going to come over here and paste it underneath carbon dioxide. Next, you should try hydrogen bromide. Hydrogen bromide is just one hydrogen and one bromine. And remember that hydrogen, like in our previous example, doesn't get a lot of valence electrons. It just gets one pair. So since these hydrogens are all parts of compounds, it's just going to have one bond, and that's it. So go ahead and try that one, and then we can check on that when I come back to class.